Yes. Right on.
All right. Well, welcome and thank you, everybody, and welcome to the kickoff session for the Colorado GIS Informational Series for 2025. I appreciate your being here, and I want to thank Matt Gage as the chair of the GIS committee for his role in pulling this together and making it happen as well. So we are being recorded, and I would like to welcome Richard Kelly from One Spatial, who is going to present this first session in the series. So thanks for being here, Richard.
You bet, and I appreciate the opportunity to talk to folks in Colorado again. I've been in this business for quite a while. I've known Matt. Matt, we go back a ways, even back to earlier 911 days when we first started doing some of the mapping in your part of the state. Yeah, we did. Matt worked with us on this in the NINA side with the site structure address point document. That guidance document came out. Can you believe it? It came out 2014, 2015. It's been a long time. What I'm going to do today is present an overview of a lot of the NINA guidance, where it stands right now, and how it will affect our lives, whether we know it or not. I wanted to let you know that, just so you know who's talking to you today, uh, I've been in the business of 911 GIS for almost getting on 30 years. I started in government. I came from county and then regional government in Central Texas. I'm based in the Austin area. I was born down here, but I've also worked at the state level with a variety of organizations and coordination around the state, including the 911 Commission building a state GIS standard. With all the years I put in here, I've also had a number of states. I've been to almost every state from a work capacity, helping work with standards, vetting and validation different states, helping craft some of that, working definitely on GIS data building, use for mapped alley display systems, CAD systems, integration between the two, emergency notification, AVL, a variety of applications of GIS data. But nothing is going to be more challenging than what we have to build for next gen 911. And maybe I can tell my mom, I got 2 degrees in cartography, mapping, and remote sensing. Now I'm going to pay for them. So here we go. I did want to let you know we're going to go through this. There'll be questions, put them in the chat box. They're going to collect those and they'll be answered later on. We'll got a lot of content to get through. You don't have to write this stuff down. You are going to get it via the website when it's done. So you'll have a copy of this. All right. So letting you know here, right now I'm currently working for One Spatial as their senior solutions manager, but I've also come from Motorola, and before that Data Master, and before that a variety of names for plant equipment and CML. But I've spent a lot of my time working with NINA, leading some of the work groups, as Matt talked about. Cheryl Benjamin out of the state of New York, myself are in the site structure address point group. I get to co-chair what I think is a document we'll touch on at the end, but it's in process right now that I think will help you and people in your organizations coming up through the ranks. It's going to be the utilization of GIS data in next gen core services applications. It'll be our 21st century guidebook on how to build and manage GIS data and why. And it will cite a lot of the documents we've got in here. There's going to be a lot of documents from NINA. They're going to have weird cryptic IDs. Refer to this slide if you want. There are every document that NINA has a 3-letter designation of what kind of document it is, followed by a number, followed by a date it was released. Okay, we're not worried about the ADM. The ISF, when we go through this in your career, if there's an issue you think bears guidance, needs guidance, you can create the issue submission form ISF. It's available on NINA's website, or you can reach out to Matt, myself, or someone else that can provide you information on where to go for that. That's if there's a standard or something you need to have that covers a problem you're having in your county or the state. That's where you go for that. When those are filled out, they generate the rest of these. A standard is something that the vendors and that the governments need to follow. So we have, and the key word we're going to go hype on all day today is interoperability. Requirements documents, those are going to be the documents that provide almost an encyclopedic amount of information. The INF is informational, and the REF is a reference document. Think of it as a bulletin or notice. One of the colleagues I work with here, I work with several good ones. Sheila Stephenson, who are CEO of North American Division. She's a long-term ESRI person for the last 20 years. She's overseeing a lot of the work here. But just as importantly is Jeff Young. He's the account manager for Colorado. I work with him. What I like about working here and working with Nina is they are technically savvy on database design and structure. So if you can't get information from me, reach out to some of our technical folks who've been heavily involved in 911 data use and production for a long time. And you'll see Jeff's contact information at the end of this. FCC. FCC is driving all of this. We now have a report and order that came out that stipulated that phase 1 and phase 2 of delivery of next gen 911 needs to be provided within a certain time frame by which it's requested by the county, in some cases by a state. Okay. What's important about it is that with phase 1 and phase 2, we'll talk about it a little bit later, is that it's going to have to be paid for, some of the infrastructure that makes it work, by the OSP providers. That's good for us. It establishes timelines. And again, your leadership within the state can tell you how this works, but establishes those timelines. But again, I highlighted yellow, the OSPs, and I pull this language out, are to be responsible for the cost of delivering 911 traffic in the required format to designated NG91 delivery points within the state. Why do we care from GIS? Because the format it's going to be delivered in, and we'll talk about that, will directly interface with the applications that use your GIS data. Now, I made 2 simple slides. That's why the only reason it's got the one spatial at the bottom, to show you these phase 1 and phase 2 in the most simple ways we can put them. With a phase 1 delivery that you can request from your OSP, and several states and counties are already asking for this, the calls get delivered across an IP network. That's your EZNet, right? It's going to come in, but it's also going to be tabular. We know that automatic location information, the ALI, which is what we've been using for decades, that will still be a format that will be made available through the infrastructure, and there's no location stored in the header of the delivery format. So this is a way for us to get an IP supporting network that supports GIS, supports all videos and text messaging and all these other things, but we're still going to use the old data. That's phase 1, and you can request it now to make sure your virtualized internet, the ESI, emergency service IP network's up and running. You got your border control for security. Those are firewalls and all the protocols necessary to deliver digital IP-based information to the systems using your GIS data. Phase 2, however, is the big brother. What that's going to mandate, when you're ready, you can reach out to your service providers and say, I am ready. And based on, at the top, I've got a kind of a cheat sheet. The phase 1 is non-standards based for what they're going to deliver. Phase 2 is. They have to deliver data in a prescribed format. Like every state has their own type of ALI format, the location block, 512 characters. Not so in next gen. They all have to deliver a prescribed set of location metrics, information bits that are digital. They're IP based. Okay. Key is that data has to be pre-validated and have the location come in that is commensurate with what the structure is. And we'll talk about that. I made this slide a while back so I could keep track of all the freaking standards and things that are going every which way. The way I liken it, and today's title was Understanding the i3 Architecture. I liken it to a train that the i3 architecture standard, STA 010, and as I said, STA means a standard. That means we all have to comply to it to make things interoperable. We've all built our software the same way to use it. The STA 010, the i3 standard, is under review. Truth be told, it's always under review. So there will be a new version, version 3, because things are always changing. It's a little frustrating that standards change, not just for the governments that have to procure the capabilities, also for the vendors that are putting forward technology to support it. But when we look at the standards we're going to talk about, and you can go back to this one slide and see, here's all the things we're going to talk about in the order in which we're going to talk about them. The i3 was put out there forward first. Then there was a format for how that digital information we talked about, that IP-based location, ILA replacement, it's called the CLDXF standard, which helps us format what's called a PIDF file, an ALI replacement, an IP-based ALI replacement format. We'll get into that in a little bit. 3D came along. There was an REQ document, not a standard. It's a here's all kinds of data that helps us build standards, or INS. I was part of that committee. There's a great document. We'll touch on it briefly. Not going to spend a lot of time on 3D today. That's a whole session by itself. Data model, that's where the real money is. STA 006, that's where we're going to put our time, our resources, and we need to be aware of how the data has to be provisioned, how it's going to be validated, and how we fix it when we find out it's not where it needs to be or it comes up inadequate in a call processing scenario. Then we have stewardship. That's an informational document. Nina can't tell you how to build the data definitively. They can tell you how it has to be formatted, but if you're building the data, the geometry, they can only give you recommendations. That's why it's an informational document, not a standard. That stewardship document, which several of you may have been part of those efforts, tells you how to build roads, how to build polygons, hasn't incorporated site structure address points, but that's going to be coming later on in a new version. There'll be an INF 046 transition document that's available to you. We'll touch on that. Jeff Ledbetter, who's going to be presenting later in the week, will be, or later in the sessions, will be, he was one of the leaders in that group. He'll be able to talk to you a little bit about that. And then finally, we have the provisioning, the GIS data provisioning. I mentioned that at the top of the call. Note that everything here on the left with the green number, that's the number you can Google for. STA 010, you go Nina STA 004. On the right, I've got the dates in which they were published. Note that the data model, we just closed public review a few days ago. The comments are being adjudicated. We are an ANSI accredited organization with Nina, which means that we have to review every comment provided through the public in a prescribed way, provide feedback to the submitter, and make sure we have a resolution that the submitter either agrees with or that an overwhelming consensus took up, regardless of what the submitter said. But we have to input public review. And that's after we vet it internally. So all these standards go through a pretty rigorous development and vetting process. Matt can tell you about it. I can tell you about it. Some of you will be able to as well. If you would like to participate in any of the groups or efforts ongoing with Nina developing GIS guidance, particularly the last one, which I'm co-chair of with Brooke Shannon from ESRI and Megan Cisco from the state of Minnesota, utilization of GIS data in GCS is a really important document. Now, this is just a cheat sheet for you on the I3 standard. I pulled some sections that are directly related to GIS. We have the SI, for short, the spatial layer replication. That's a GIS server that aggregates data potentially. That may be changing in the next version of the I3 standard. Everything here, and I usually refer to STA 010 or Style 10 is a common way to refer to it. This is the Bible. This is the book, 700-800 pages long, where everything's described how all of 911 works in the next gen world. It describes discrepancy reporting. There's a list of discrepancy reports. Yes, the ones that come out of your GIS server or when GIS data is not correct at the PSAP, that's going to be described in the discrepancy reporting section 3.7. The ECRF LVF functionality, the MSAG conversion service, we'll touch on a lot of these. Geocoding, the forest guide. We won't get to all of these, but you'll feel free to look at those sections. And if you have any questions, you can let us know. There is a GIS layers registry. In the I3 standard, they have a list of standardized names for GIS data layers. And we had an Appendix B, which was a brand new schema, multiple pages. It was machine-to-machine geometry conveyance instructions. That was removed. In the latest version that's under review and getting ready to be published of the I3 standard, it's been incorporated into the data model. The next version, V3. Now, the location validation function, I didn't want to spend a lot of time on this, but this is an absolutely critical and essential document because everybody may have a different view on how to build location validation function. Basically, when you load your GIS data into your ECRF, you want to make sure that you're able to have 911 valid information in there. That LVF performs a function there. It makes sure that you can find a valid location. So your MSAG coordinators, people who issue addresses, you're going to work with your service provider to make sure that a new address that's issued locally, whether it's the city or the county, that address has an appropriate 911 representation as an alley record, automatic location information, and that that alley record fits within an MSAG, a master address guide record. All these are based with the telco and the service provider. You guys have been doing it for a long time, whether you're working with AT&T or Intrado or whoever. When that information gets in there, that has to be validated. You have to make sure that you have a unique and suitable location that's specific enough for responders to get there. That's going to help us create a civic location. That LVF is going to tell you whether it's valid or invalid. And you have other fields you can check or not check. We're not going to get into a lot of that, but it's not there to fix your data. It's going to be there to tell you whether it's valid or invalid. And if it's invalid, at what point in the process of checking all of the attributes that it failed. And it's checking those attributes necessary to help with call routing. You're going to have two ways to handle calls coming in the next gen world. One is going to be geodetic. Geodetic is a complicated word used for coordinates, lat long, and even z-value. That's what we used to call wireless, right? Now, when we talk about civic, that's a plain old address, 105 Main Street. That's what we used to call wireline, right, or landline. So geodetic coordinates, civic, going to be a traditional address. When we talk about civic address, you will hear me talk about from time to time a routable address. That's not routable in the CAD. That means you can get the call routed using your GIS data to the right PSAP. And then you have the other term when you talk about sub-addressing. Okay, that's going to be a term we're going to talk about that we need to be able to validate sometimes in the sub-addressing. Which building are you in? Which floor are you in? All right, and that's going to be considered a dispatchable location. Routable and dispatchable can be confusing, but some of these
Richard, did
get
we
into the
lose
details
you?
for you. From the I3 standard. Can you
Richard,
hear me
I'm
now?
so
Yeah,
sorry,
you keep
but
telling
I
me when
think
you
we
don't hear my
lost.
voice.
Yeah, I think we lost the last statement.
That's okay. Well, thank you. And I have a very angry situation with my ISP. So just let you know when you lose me, stop me, or if I start sound like a robot. Um, I wanted to let you know that the MSAG conversion service is supported by the data model. The MSAG conversion service stipulates there are fields that you have to have in your GIS data that supports this I3 function. When you do site conversions in Colorado, and you may have one county that may go all next gen, while the next door county may have to stay with traditional till they get funding or they're able to transition over or whatever, you'll have to transfer calls probably between those two counties. How do you do that? You use something called an MSAG conversion service, which is populated with, wait for it, your GIS data, address points, rows, center lines, both if you want. And those fields, which you see outlined there, legacy street name, there's 4, prefix, name, type, directional. Guess what? Those are the street name pieces that are in an alley record. So the scenario is this. If you have a traditional alley site and they're dealing alley records and they need to transfer to a next gen site, those first 4 fields, along with the ESN and the MSAG community and whatever's popular there, that's going to be used in the transfer to a next gen site and converted to the other fields in that same road center line address point that are next gen. And there's a lot more fields, right? It's like a one to many scenario. But this is one example. There's 2 calls, PIDFlow to MSAG, which is where you take an NG site and convert the location information you're going to get in through the NGCS system. And there were so many diagrams, I didn't put a call flow diagram. You'll get that the rest of these sessions that are going to be coming up. And the MSAG to PIDFlow. So this standard component is going to be in there, and it's going to be predicated on your GIS data. It's covered in the I3 standard. The I3 standard also covers, I mentioned this earlier, the approved GIS layers, 10.32. And I thought this was pretty cool. These are all the layers that NextGen 911 will understand. Look how many police variations there are, which you could imagine has a lot to do with CAD. But look on the far left, that shorter part, it's one table. I had to split it in 2 parts. Road center lines, site structure point, PSAP polygon. Those are your big 3. You got to have those. Remember, when we use data, GIS data, to find a location on a point or a line, this is for civic location. We have to do it, find the address point or geocode on the line so that then that location can be compared to a polygon for the PSAP that will help route. All the polygons will have a routing ID and for information string, okay? If you get the geodetic, the coordinates, the X and Y, that's just going to be compared straight to the PSAP polygon. Now, you also see fire, law, and medical below that. That'll be recommended, but mostly those who's going to be sent out will be determined at the local level. I'm going to go back to what's going to come in here. In the next gen world, the next gen core services information, the GIS you're populating into these different systems, location validation function versus call routing function. When we receive a call into the next-gen core service server, this is all under the hood. You're not going to see this. It's going to be in that civic location data exchange format, which is the recognized alley replacement. It's going to handle civic. Remember, if it's a geodetic location, it's going to be coordinates. It'll go right to the system to figure out where to plot it. But the CLDXF will be necessary to figure out what are all the fields for the street names. We got 2 of them. We got one for the US. We're now at version 2. That just got released. And we got version 1 for Canada. That just came out days ago. It's pretty close. You're going to hear pitiflow all the time, and you're never going to remember what it is. I put it in yellow because I can't remember what it is. Pitiflow, think of that as the alley replacement. It's the presence information data format location object. I can always remember the low part. So it's a location object. That is your next generation IP-based alley replacement. So all the information we could cram into 512 characters of legacy data for location, we got the sky's the limit. We put anything as long as it fits in any of the fields in the pitiflow, which is based on what the CLDXF says it does. In this document, I got a couple snapshots down here. Notice that there is an Appendix A in that document. And again, the document you're going to look for in the US is NINA-STA-004.2-2024. It tells you how to break out some of these fields. So if you're interested how, for example, you do address parsing, how do you deal with incorporated municipalities and names? There's a whole series of tables. I just got a snapshot at the top of it that you can go through. All the way to the right, Canada's a little more complicated. There's an example of Canadian civic location hierarchy and how those different fields, it might be interesting to look at, but you can see there's some complexity. It's almost like looking at a flow chart in a relational database, which is how some of this is moving. But that middle one for sure, you're going to want to take a look at the CLDXF address parsing in case you want to reference that to your GIS data. The CLDXF standard, again, we're on version 2 for the US. That applies to Colorado. It's going to give you, and I took address number, it's going to tell you what the name is for that pitiflow field. It's going to have the definition, the source, examples, data type, the domain if applicable, business rules, and notes. This is really great information. And you know why it's great? Because I can go look at that example for everything, for the address number, prefix directional, community type, whatever. And it's going to give me examples that'll go like, oh, I'm the 4th example. These examples we spent a lot of time working on. Some of you did too. This is really workman-like data. You can see how your information from your legacy world is going to be equated in next-gen delivery of information in that CLDXF format. Good to have. Now let's get to the real meat of the show, the data model. Ooh, I've been working on the data model since 2010, and the first version came out 8 years later. The data model provides the structure by which the attribution has to be formatted and delivered. The attribution, not the geometry. We can mandate the attribution because we have to have interoperability. NINA STA-006.2, version 2 is up right now, but version 3 just completed. As I said earlier, it just completed its public review. They're adjudicating those comments. When V3 comes out, hopefully it gets adopted in the next few months before the holidays. That will be fantastic. I get asked this all the time. Richard, when are they going to start changing this stuff? Well, we can't keep changing our schemas. I would say version 3 is going to be a watershed for us. You can see there in the sections that we'll have roads required, site structure, service boundaries, firewall EMS, provisioning boundaries, and supporting that registry system we talked about that's in the I3 standard. We're probably going to see in this new version things that will not change for the foreseeable future. It has to be alignment with the I3 standard. It will be. We removed that Appendix B, which was machine-to-machine geometry conveyance. That's been baked into the data model V3. There's 3D. We've taken our first steps. I can't tell how many presentations you've probably seen on 3D, and we could have gone down the rabbit hole on that. I'm going to put it simply. What we're baking into the V3 data model is support for address points, road center lines, and building footprints or polygons. Polygons can be used for buildings, for rooms, for parcels, but the polygon layer will be our first step to 3D, because you can take a polygon that represents a building footprint, and almost all software can do this in a map display or CAD system. You can extrude that or raise it up from the ground level up to as high as the height of the building is. And we've seen that in demos. That's the future. We're going to have these transparent, translucent three-dimensional buildings with a dot glowing inside, just like you see on TV or in the movies. That's already in play in a lot of places. But this 3D document helps us start moving that direction. We also had to make sure that the latest version of CLDXF US, which came out a few months ago, and Canadian one that came out a few days ago, that this version 3 of the data model supports it. Again, data model is being finished up right now, be out later this year, and the incorporation of Appendix B. And when we build that, we get asked about this more and more. We're going to have data templates. We will have pre-formatted geodatabase templates you can look at and use to start populating your data. That's always helpful. We had to do in that comparison some comprehensive review of the attribute descriptive names. Those have been updated, how they're used, the types. We added legacy county ID fields because we have some counties that would use FIPS codes, or they would use 4-letter unique designations. So we needed to make sure there was a legacy county ID that was flexible for the legacy information, as you saw, that would be in some of your GIS data now. We clarified the use of multiple fields. There were a lot of questions about some of the fields, and we resolved inconsistencies that were across the board. As an example, the road centerline layer, it looks pretty much the same. You'll have a descriptive name, field names, and then whether it's required or not. I will tell you that we got rid of the dreaded optional. We had a lot of debate. It's either required or it's not. So instead of optional, it's not required. But conditional, if you have a need for that data, it should be in there. An example there, in some cases, you have a left address number prefix, particularly some of the northern states. If you have an N105, that is part of the address, but not all over the country. So that field will need to be populated by those counties or states that have that feature. Okay. And the types have been updated. This is a great screen to keep track of when you want to understand what your data is doing. On the left, remember we talked about how you're going to have to compare GIS data to the PIDF flow records. That's going to give you the critical items necessary for routability. You have to have the country, you have to have the state, you have to have all the different levels, community. Those are critical to route. Most calls are going to route based on some of the higher level geography. Now, when we talk about MSAT conversion service, over in the purple, we already talked about, that's the legacy fields. Dispatchable per FCC, if we want to get to dispatchable level, that's a location suitable for a responder to find somebody. For example, they can't talk. They're on the floor in the bathroom or whatever. It's not.
Richard, I think we've lost your
You
audio
know where they
again.
are. That dispatchable location, but we'll also, well, I'm going to write a terse letter to Spectrum. Can you hear me now?
Yep, we've got you
Can
now.
you hear me?
You were talking about the person that was on the floor in the bathroom.
Yes, this will help them. This is FCC wants us to have dispatchable location. And I also mentioned I'm going to write a terse letter to Spectrum. So altitude, height, and elevation, these have been added. We're going to have to understand lat, long, and elevation, and even more of that. I'm going to get into this in a little bit. Service boundaries, we've updated that table there. You'll have that. Sample attribute definitions for the data model. All of these, just like in the CLDXF, will be provided to you. A really nice feature of the data model V3 you're going to want to refer to is the layers registry update, where we said, okay, what are my road center lines going to be needed in? We will put the NG functional elements that's going to be used using your data. And that left column, the emergency call routing function, location validation function, geocoding service, MSAT conversion service, mapping data service. We will list what functional elements will require each of these data layers. And notice we'll have required for, some will be recommended. Some of these layers will be recommended for specific functional elements. And then there's additional layers on the far right column that might be helpful in certain situations. This is a great checklist for you got someone new coming into your program. You'll be able to give them this table in the data model. It will explain how that stuff gets used. Now, the part a lot of people don't like is the fact that we now have a defined NINA Global Unique ID in GUID or NUGID, depending on who you are, want to paraphrase it, that we have to do. It's required. I don't like it, but it's the way it was required by the I3 engineers at NINA. FER is the uniform resource name. You'll see example up there, EARN, emergency, UID, GIS. That would be part of the unique ID. The layer indicator, pretty straightforward. Is it a SSAP? Is it an RCL? Whatever. Local unique ID. That's whatever you want. I have a GUID in there, but you could use 0015. Maybe it was your object ID that you saved as a permanent non-changing column. And then the agency identifier. This has to be an FQDN, a fully qualified domain name. And no, I did not know what that was when I first started with these standards. Now we have to have that. Well, what does that look like, Richard, when it's all said and done? There you go. Read it, soak it in. Love it. That is now the unique ID for one feature that's an RCL. You got 2,500 RCLs. Congratulations. You're going to have to make 25 of those different ones. So I'm being kind of tongue in cheek. I understand why they want to require it. This will be one of the many challenges on how we manage that. Check with your provider on how they manage concatenated fields into a unique ID that does not change for every one of your features. That will be something you're going to want to bake into RFPs or make sure your application support. I'm not going to go into 3D, but I've already mentioned to you that there are requirements documents sometimes in REQ. There is one for 3D. I got to help write some of that content with many other talented people. It will tell you how you can approach 3D or location within a building. We know that there's a lot of push to get schools mapped, campuses, industrial complexes with multiple outbuildings. This document tells you how to reference a lot of that. We're going to talk about vertical location in a minute. This gets into how do you understand the differences in vertical location and how it's referred to. We're going to leave the data model for a minute and go to the stewardship guidance. The data model gave you the required attribution structure for each of your GIS data layers to be used in the next-gen core services. What the stewardship document is, we can't require how to build the geometry, but we can tell you best practices about it. Okay, so section 4, general requirements, where we talk about accuracy, database precision. Then we get into civic location layers, which is the term for the roads, and we're looking at address points and other things. That'll be important. Service boundary layers, we talk about polygons. So if you've noticed, we're going to talk about right now in section 5 will be linear features, roads. I mentioned site structure points. They are going to be in there. They're not in there yet. So right now it's just roads, but all the polygons, ESNs, ESCs, PSAPs, fire law, EMS, those approaches on how to create them are in there. The geometry. It's going to give you every example, a knock on wood, not every example, but so many examples of ways to screw it up. You're going to love that. I loved it. I wished I had that when I ran a GIS program for my counties. I had 10 counties and 36 different jurisdictions. They all did it something different. So when you're trying to build this data out, there's a long-term maintenance recommendation, a plan for road center lines and service boundaries. And like I said at the very bottom here, TBD, but we will be adding site structure adjust point maintenance. Matt and I, we built that site structure adjust point recommendation guidance. That part of that served as some of the guidance on how this document was structured. Notice I got a thumbnail on the right, layer dependency considerations. Again, this document tries to tell you how this geometry is going to be used for civic locations, service boundaries. It's really helpful. And we'll have that nice chart there. Changes in them might affect these uses. So that's pretty nifty. Just eye candy here of what's in that document. Bear in mind, these come right from the document. Everything you see in this presentation comes from the documents I'm talking about. This is a graphics-rich environment. It will tell you, give you graphics. You see the fishbone example above of where you're putting address points relative to where they would geocode. Important considerations. The one thing I would give you as a piece of advice, you're going to be building or contracting for GIS data that has intelligence built into it to have the software applications for next-gen core services work a specific way. What do I mean by that? If you look at the roads above, if you only have roads for your geocoding necessity within the ECRF. The emergency call routing function gets that location from the PIDF flow record, which has all the different fields for the address. If it compares it to the road center line and it has to geocode a location, notice that the 101 would be on the far left, just like the 111 if you were geocoding. But if you look at the addresses in the real world on that street, that address, 111 J Street, that's all the way at the end of the block. And that may not be that big of a problem, but if that road is a mile long, that could delay the responder getting there or just not getting the right place at all. So it's very important that when you build data that we're routing to the right place and we're providing that information to other systems in the PSAP, this is even if 111 has the red dots in the left half of that graphic, if they have to be responded to by a different fire department than all the other ones, maybe there's a creek going between them or something. This document tells you about that. It goes over spatial gaps and overlaps. It goes over digitized direction. Yes, we have to go back and make sure the roads are all drawn the correct way for geocoding. Potential versus actual ranges. I have to stop for a second on that. The ranges on the road center lines. There's a left and a right side, right? We geocode 101 to 199 and 100 to 198 on the other side. My concern is that within NENA, there's been guidance for many years, informational document guidance from 2009, but when we didn't know no better, and we're trying to understand how we should not leave old data behind as we get ready for next gen, all these standards didn't exist back then. Metric of 98% match between the MSAG stuck. It was a recommendation. Yep.
We lost you at
here it is.
All of those standards didn't exist back then.
Yes. Can you hear me now?
Yes, we can hear you now.
I got to say it again. We didn't know no better. So here we are picking it up. Sorry about that. We had a 98% recommendation, that document, as a starting place, a place to go. Make sure your alley and MSAG match your address points or center lines to 98% value. And everybody caught that. They said, oh, a number I can match. And they hired people to do it, or they got their departments to build it. All they cared about was 90% match between alley MSAG and your address points and road center lines, your GIS. Didn't even care about the polygons, which are even more important. So we've been trying to overcome that. And some people, in an effort to say, I need to get that 98% match, have taken road ranges. And you're seeing the example above where you need to have good road ranging. They would take a road that may, in this example on the left, from 101 to 111. They say, oh, you know what? That doesn't match my MSAG. I'm going to make it 101 to 199. And they would expand it. They would change the more accurate GIS data to what we call its potential, right? A range or buffered, just so it matches the old legacy data we're going to ditch anyway. So this has been happening in many places to achieve a recommended metric from 15 years ago. Don't do that. We need actual ranges on roads so they geocode properly in the NGCS. This is why I wanted to make sure you understood that the stewardship document talks about the right way to build the geometry so the attribution works properly. So the systems that are unattended, there's nobody involved, and you don't get a call at the PSAP unless your GIS data works. Same goes for gaps, overlaps with polygons, and who answers what calls in what jurisdiction. You'll have to deal with all that. We're going to touch for a minute on GIS data transition. This is another document, 46-1-2024. It also just came out. This is a nice document. If you are at a county, and some of you are, where you really haven't dug into prepping your data for next gen, you got a day job. This isn't something you really have had to need to do. When you get ready to migrate and upgrade, or if you're working in concert with the state, you're going to want to know what has to change and when. This document takes you through that process. It even gives you a 3-phased approach for creating and maintaining transitional data to get you from legacy or traditional environments to the next gen. I got a couple tables here. It'll have a table that recommends responsibilities for the GIS data provider for E911, transitional, and NG911. Really nice to have these recommendations, as well as what the site structure address points as an example. They do it for all the data, how it's used now, later, and in the future. So these are great. These are just snippets of those tables. Great document. I would recommend that if you're going to work with your board or your executive committee or the judge or commissioners, I've worked with elected officials and I've had to try to break some of this stuff down so it's actionable for them. You can take this transitional document, find the parts that work for you and say, look, here's some recommendations how we transition. And then you can better plan out your GIS data transition. You can bake it into your work. So you're not saying I have to hire 5 people full time for the next 6 months. Nobody can do that. So this is a good transitional document. I wanted to bring it up. Here's an example from it. A lot of people have the emerging surface zone, the ESE or ESN layer. Obviously, you could take that, do some, as in our GIS parlance, dissolve some of the polygons that have the same police department. Some of the ones that have the same EMS. You can create separate layers. This document actually tells you how to do that in a simple way, right? So it says, hey, you could take all of the PSAPs, dissolve it, get a PSAP layer. In that case, you had 5 individual ESCs, but they all went to the same PSAP. But your law may be different, right? So you may have to break it out. So you could take tables, and these are right from the document. It'll tell you how to break down and create from your ESN layer all the requisite responder layers, fire, law, and medical. Pretty cool. Now, as we round the bend here towards the end, I mentioned that I'm dealing with the provisioning and maintenance of GIS data to ECRFs and LVFs from STA to INF. So we originally had a standard version 1. I was the co-chair with some others on that document. We standardized or tried to how data gets from you to the next gen core services systems. We reviewed that in 2017 and deemed that it was not really workable to continue. So we changed it from an STA, a standard, to an INF, just like the transition document, just like the stewardship document. We needed an INF. So one, we didn't just talk about LVF ECR provisioning. We know, and you saw the alphabet soup in the I3, we know we have to provision data to the MSAT conversion service, the mapping data service, a whole host of things. So we expanded the scope, dropped it from a standard to an INF, got that approved, and we've been working on it the last 2 years. We cover a huge range of information. We cover what's going to happen with the tables and how are we going to build this out. This is some of the early things we had to clarify. One of the things we have in it is a diagram. This document is meant to show you how things work in layman's terms. For example, the one on the left, that is a query that's coming in as geodetic. That's coordinates, right? The query is going to come in through the call handling system, through the next gen core services call processing. It's going to hit your GIS data, and it's going to find the right PSAP to send it to, or it's not, and it's going to say, sorry, we don't have, that doesn't fall within a PSAP that we have. And if that's the case, there's a whole nother thing it could do and go out to the forest guy, which we'll talk about today. The one on the right is a civic location, like the 105 Main Street. Notice in the example, it's going through address points first, then road center lines. You can do either or. We recommend both as an industry, and most of your vendors can provide systems that support that. And then once it goes to the points and or the roads, and it turns that location into an XY, just as though it were a geodetic on the left, once that civic becomes a geodetic location, then it applies it to the polygons and sends it the right URI, or it doesn't and goes back. You get an error code. That's the basics of how we take your GIS data and next-gen core services and figure out where to route the call. Those examples came straight from the document. How are we doing so far? I think we got a few more minutes. All right.
Until the top of the hour.
Look at them.
Okay, good, because here comes the tough love. Okay, I'm now speaking to all you GIS people. We have a problem. Understanding geometry. You may be familiar with the term geodesy. I'm going to build out this slide. We have to know the data structure we're building. This is going to take you a semester of well, we got somebody talking.
I'm trying to find them so I can mute them, but maybe if you don't have a question, if you could mute, please.
Thank you. This slide is taking a semester of geometry and geodesy information and trying to cram it onto one slide. I don't pretend to expect everybody to know all this, but what I try to explain in simple terms are the graphics at the bottom. The Earth is not a perfect sphere, but in GIS, we have to do precise measurements on the outside, the circumference, outside surface of the Earth. The Earth is not a sphere; it's a spheroid. It bulges at the equator because as it spins, it gets fatter at the edges. Just like you grab your little brother and spin him around, his feet get longer. So that's what we're talking about. The X and Y is going to be different a little bit in accuracy depending how close you are north or south of the equator, the middle. We build these things out as models under the hood called a datum. It's a mathematical model of that spheroid. I'm trying to keep it in simple terms. We need that to do a lot of things. And you may not know that, but a format of this information is used by GPS systems to figure out what a latitude and longitude is for your cell phone. Right? It's going to be generating via that GPS chip what your lat long is. Now, for us, that spheroid is resolved in a datum called NAD83 for most places in the country. I don't think anyone uses 27 anymore. The North American datum, 1983, was agreed to by a bunch of propeller head mathematicians and geometry people and said, all right, we're going to create as perfect a model of the Earth as we can for that spheroid, and we're going to do it. And they did it in 1983. NOAA, at the end of that statement of that fourth bullet, they're trying to come up with a new one that's even more accurate because right now the Z values can be questionable. While it does have a lat long, I don't know if you knew this, GPS systems also generate a Z. It's X, Y, and Z, lat long and altitude. Altitude, very inaccurate. We're not where we can improve that, but what you are going to have to be able to talk about are those three terms in that box to the right of the spheroid. One is altitude. When you talk to your providers and they're delivering to your comm centers a Z value, it could be in your ally screen, it could be in the next gen equipment. That Z value, you'll have X and Y with the confidence certainty, and you'll have a Z if you don't have it already. That needs to be referred to as altitude. It's the height above, wait for it, the ellipsoid on the left. So that XY on that little model, the little spheroid graphic on the left, how high it is above that spheroid is called altitude. And it's height above ellipsoid. And we're not going into vertical today too much. But I did want to tell you the other two terms used interoperably with it, interchangeably, which is not right, is elevation and height. So when you're talking about comm ops, when you talk to the other speakers this week and they start talking about Z or interior location, understand that altitude is the only term we care about at this time for 911. That'll be the Z. It's altitude. It's height above ellipsoid. And software should be able to convert that to another metric. They could convert it to elevation. That's the height above sea level typically. All right. Or height above the WGS84. Software can convert, but you really need to ask how that's being created. If they tell you, oh, we're telling you an elevation. Height is another difference. Remember that REQ I mentioned for 3D? All of this comes from that. And if we talk about height, that's above ground level. If you're a firefighter, you're not going to really give a tinkers about how high you are above the ellipsoid, but you're sure as heck going to want to care about how high you are above or below ground level. So it's important to know those three terms. This is the real geek out slide. Just reinforces what I said. Here's our XY friend again, little bouncing ball. If I'm trying to measure it on the surface of the Earth and my map is flat, where that flat line is bisecting it, I have to take into account the curvature and where it is. So we have what's called a projection. So we take the projection. In this case, there's a cone. If you took a lamp and you put a piece of construction paper around it, it's transparent, and it would project all different, the whatever's on the construction paper picture at the top, it would be really big, and everything around the middle next to the light bulb would be normal size. We choose a projection, an overlay, so when we map on a flat computer screen, it's as accurate as it can be for left and right and up and down. That's the bottom line. You don't need to know that, but what you do need to know is that all data that's going to be used in next gen core services has to be transformed transformed is the correct word, from whatever datum and projected coordinate system it is. For example, if you're in Colorado State Plane and that's your projected coordinate system on top of your NAD83 datum, whether you do it yourself or whether you give it to your service provider, that's going to have to be squeezed through that Plato machine and converted to WGS84. If you look at the top left, I love this little thing that makes me remember what is X and Y. We're in North America. You are too. So your X's are going to be negative and your Y's are going to be positive. Why is that? Well, we need to be aware that for the equatorial, are we going to be above or below? And I want to make sure I got these right. The y-axis, north and south, that's going to be positive because we're north of the equator. We are left or west of England. Don't blame me. Blame the 1700s, 18th century people. If you're west of England, your X is going to be negative. So when you get an XY in your PSAP or on anything else, if it's in WGS84 format or geodetic, it's going to be negative X and a positive Y. That's why when sometimes you're testing wireless, if they get them switched and you got a positive X and a negative Y, you're somewhere in the Indian Ocean or off Australia. Just letting you know. Why am I showing you this graphic? Because when we go back and convert from this nifty little sphere with a nice flat surface projected on it, when we stretch it all out and put it in this quadrant system, this is like high school Cartesian coordinate system. Here's two roads. Notice that on this road, I only have two nodes. It's a single straight line. This one, it's a complex, a compound or multi-part road. It's got two sections. We call these nodes or vertices. This one's got two, this one's got three. When you transform from whatever your datum and coordinate system is to this thing, what moves? Do the lines move or do the nodes move? Guess what? The nodes move. Not a lot of people keep this in mind. So the data you give to your provider that's going to go in your call routing, that's going to be used for geocoding, when they transform it or you transform to WGS84, your nodes will move. And I promise you, if this hasn't been taken into account, you'll have a beautiful set of GIS data, no gaps and overlaps, right down to the millimeter. That's hunky-dory. But when you give it to somebody else and they transform it, they go, oh, you got gaps and overlaps everywhere. I've seen this all over the country. We need to be aware of this. We need to understand that if I'm transforming from an NAD83 datum, just think of it, whatever the local data format is, to this interoperable NINA required WGS84, gaps and overlaps will occur if you don't make sure you have the same nodes and vertices in everything that's supposed to be next to each other. Okay, nice little animation there. We end this up by reminding everybody problem. But you know what's the bigger problem? In counties.
Hey,
and county.
Richard.
Our gap and overlap problem between, yep.
We lost you
again.
right after you said we're going to close this out by.
Showing you the problem that could be facing all of us and probably
Perfect.
is. You see Colorado there. We have more than 3,200 counties in the United States at last count. There has never been a standardized set, and I'm not going to count commercial sets. There's never been a standardized set that I know for every county and state line in the United States. Some states have been progressive and got county line files. Others have not. Texas is an example. They don't have a standardized county line file for 254 counties. My problem with that is now I got to figure out years after they've been building data, how do we make sure there's no gaps and overlaps? Remember that slide I showed you where we're aligning vertices? Rivers do not make that easy. We have to understand the geometry of polygons and all the other features to make sure we can correct them before they go into the NG core services. Yes, it's a big problem. Yes, it's a big job. I will tell you now, we are already seeing the industry problems where there's rivers and there's not agreement between two counties separated by river, particularly a wide one, where one county may say, oh, I go to the middle. No, I go to the shore. Now suddenly you got a boater calling in and their call's not going to either PSAP. It's default routing. We have to be aware that has an impact. So bear in mind, if you've got geographic features, you got rugged terrain in Colorado, you got rivers, bear in mind where those demarcs are and make sure that you've looked for with your neighbors, dealt with the gaps and overlaps between those jurisdictions. Those were some of the things I wanted to get out there to you. All of this is in the slides. I did not get into the forest guide. We had no standard for it, but it is something that's being built out. We had some documentation on concepts in 2015. We did not get into 3D. I did not go into the 3D REQ. You might want to look at that. There is being built now a new standard for 3D structure construction, what you would be doing for indoor mapping. We see a lot of people selling indoor mapping capability, but there's no standardization of how that data should be built. Not like there is points, road center lines, polygons, the rest of the year. With that said, I'm going to turn it over and give you a few minutes if you have a couple questions. Contact information for myself and Jeff Young. We're glad to provide you content. The presentation we'll send over to you and answer any questions you got. We've got a few minutes left. We can do that.
Thanks, Richard. We have one in the chat to kick us off. They wanted to know how the service area and fire district dual jurisdictions, can it deal with that? And then there's a second part of the question. Do PSAP or districts need to submit boundary data in a special way to ensure dual jurisdiction areas are respected?
Yeah, one of the things about next gen 911 is that we're not restricted to just fire law and EMS. You can have those multiple jurisdictions. And when the ECRF does a query for not only where to send the call, but the responders for a given location, all of those can be sent. You can have multiples, but it's going to be based on deployment. You'll have to work with your service provider and figure out what data they're willing to support that you want to either acquire or provide if you already have it. And each implementation is going to be different when it comes to that. If you've got some specific questions, you could shoot them back and we can give you some recommendations. Jeff or I can both tell you about that. We've had experience with a lot of sites, but there's not a one answer for that because it really depends on a lot of variables locally. But we're glad to talk to you about that offline.
Perfect, thank you. And who else has questions?
And you don't have to have them. This connection's terrible, so that's my fault.
We have another question in the chat from Rachel about persisting unique UIDs for each of the
Yes.
required layers and actually features.
Yes.
Richard, you mentioned check with your provider. So question one, what provider are you referring to? And two,
Great question.
And then two, are there tools to help with persistence of the unique UIDs?
So two things. Let's take two things real quick. The now 4-part unique ID that we're required to have is there to allow next gen core services systems to utilize a feature, and if there's a problem with it, it can be better identified where it came from, who's the owner of that feature, how can we correct it. That was one of the goals for having that, but it's also necessary for other under the hood functionality that the i3 group has deemed necessary. When it comes to managing that, yes, providers can do concatenation. That's where we're gluing in different fields together. The easiest way to do that is to manage multiple fields, have it concatenated. You could do it one time and basically disassociate the concatenation process for those fields you've already given a unique ID and manage them so they're not changing. If you use a GUID that changes, that may not be a good idea. They designed that 4-part unique ID to make it individual. What that also does is that if you have to split a feature, let's say a road into 2 parts, you may want to grow out a second unique ID that's very close to the first one because you'll have a child object. Or maybe you want to track 2 new unique IDs to that original. There are things we're not even ready in this industry, I think, to do yet. One of them is tracking child objects when you split polygons, split roads. That can be done locally, but that's really going to be on a consultative basis with your GIS database provider. I mention your service provider because if you're looking at a fully qualified domain name, there's going to be coordination between, let's say, I'm throwing some names out there. If it's a One Spatial or a Geocom or an Intrado or an AT&T or ATOS, you're going to have to look at your provider and say, okay, what do I need to have for these? Something we didn't cover, the polygon layer, every polygon has to have a routing ID in it. All right. It's got to have a URI. The Uniform Resource Identifier will say, here's the PSAP calls that fall on this polygon go to. You're going to have to work with your providers to figure out what's acceptable so they can facilitate that routing through the NG network. So there's some coordination between those things. And we can provide more information. I would recommend some of the providers are going to be providing other presentations. They will be equally knowledgeable in these things too and can provide you more context on those calls.
Perfect. Thanks, Matt. And who else has questions?
Got a question. This is Bill Keever. So we've got. Are you informed enough to kind of tell us where Colorado is at? I mean, we're as a GIS shop, we're submitting shape files to like multiple
Right.
people. T-Mobile, AT&T, and Trado.
Yeah, right.
New call handling software is being implemented, and I don't think as GIS people we really understand who the players are, where we're
That's
at,
right.
and what needs to fall to make all of this happen for, say, like the Metro Denver area.
That's right. That's right. So whether you're in Garrison or Rifle or wherever you are, the I do not really put input in on the state operations. I try to keep track of what's going on in the states, usually by what's available online. I used to represent NINA to this National State Geographic Information Council. That's where I was tracking Colorado activities there, where there would be presentations from each of the states to the group of state and federal agencies. But with the advent of the NINA Phase 1 and Phase 2 uh, initiative to get people to migrate to 911 and G911, I think we're going to see more of that. NINA itself provides updates when it can on what the status of the states are going forward. 911.gov, the federal agency, certainly issues their annual or biannual report on where the states are in Next Gen 911. Feel free to reach out. If one of you wants to let me know, I can tell you where the 911.gov reports are on the states. It's not complete because some states haven't submitted some assessments. There were assessments done to figure out these kinds of things. And again, some of that information is out there, and I can provide you points of contact that I know of that would be helpful.
And Bill, I'm going to ask Matt to describe what the GIS committee is working on, and then I'll try to fill in
Awesome.
any other gaps. Matt?
To this point, largely the GIS committee's focus has been on providing educational materials. The relevant NINA standards are downloadable from the GIS committee's webpage with the task force.
Okay,
And
thank you. Oh, sorry, go on. You had some additional?
Yeah, I was just going to say the GIS committee is also working on a project to build a statewide PSAP boundary GIS data set. And the EZNet users group is working on next steps for Next Gen 911 implementation. So to answer your question, you're probably providing a lot of GIS data to various different groups, trying to get various and different things up off the ground and running. And I know that's not a very satisfying answer.
It is. A lot of states are having the same challenge, and they're starting to coalesce on getting information collected and distributed. People are less afraid of being seen as not being making progress. And frankly, with the changes in standards, there's been some reticence with people to start, just bull ahead into these things. We've learned a lot in the last few years, both in the standards industry, whether it's NINA or APCO, and I work on both sides, as well as the manufacturers. So we're in a much better place now to do implementations, track them, and report on them.
Richard, even I know some regional GIS groups have been sort of waiting to see how long it would take for data model, waiting
That's
for,
right.
how long is it going to take before data model version 3 is ANSI stable form?
Great question.
Because we're working on migrating our regional integrations
Yes.
To the data model, but we don't want to duplicate the work, right?
You notice I spent a lot of time on that. I'm not happy that we're having to change so much in V3, but that's going to be it. By the time they get version 3 of the data model, remember those are the schema tables for all the data used in NextGen 911
Mhm.
and plus a few extra. When that gets completed in the next few months, I wouldn't see that changing, if at all, for years. So that will give us a stable demarc, and all the states that adopted parts of it or earlier versions, across the country, everybody's going to have to upgrade to that version. That will take time, and there's costs associated, right? It's resources. So when it comes out, you'll start seeing myself and others who are able to do presentations on what exactly is in the final adopted version of V3 and how that impacts local governments. And
Mhm.
I'm sure we'd be glad to come back, or my other colleagues doing the other presentations. We'll all be able to provide information on that.
Outstanding. It's actually the Colorado 911 Resource Center that's working on those PSAP polygons
That's
projects.
fantastic.
So the GIS committee has been providing some support to the Resource Center. The Resource Center got a grant, and they're working on an RFP to have corner to corner curated PSAP boundaries created as a sort of one of the stepping stones towards next gen GIS data for Colorado.
That's great. Good news. Well, I appreciate having the opportunity to bring this information to you. I'm real excited to see a lot of the other presentations. You're going to have some great content in this series. And I would strongly urge you to grab some of the content. If the presentations are available, like this one will be, grab it, store it somewhere. You never know when you might want to look up a standard and get that number, or Google it and see what the latest version is. So on behalf of myself, my organization, and Nina in particular, we appreciate the opportunity to give you an update on some of these standards. And we will be at the national conference in Long Beach in a few weeks. We'll have more updates, particularly on 3D and interior mapping. And we'll look forward to seeing, hopefully, some of you folks from Colorado there.
Thank you so much, Richard, and thank you to everybody for being here and for asking some great questions. This will be archived on the Colorado 911 program page, and we look forward to next week's presentation in the next of the GIS informational series. Have a great day, everybody.
Take care, everyone.